All right. Okay, so we're going to be looking at the inverse function of an exponential function, f of x equals a dx. Okay, let's try it. What happens when you do an inverse function? What's the first thing you're supposed to do? Switch around twice. So the inverse looks like what kind? Okay. Now, do you know how to solve for y? How do you get that y down to be a y equals as opposed to a exponent right at the moment? You don't know how to do it. That's where we get into the logarithm. Okay, that was a trick question. All right. Okay. So that's good. If you look at this, which is basically what we had up here, not basically, exactly what we had, okay? This is the same thing, okay? All right, again, that little base. Now, how do we read this? Y equals log base A, just kind of a pause, of x. That's how we read that piece. Y equals log base A of x. It's important for you to read it right because it'll give you some clues later on for what do you mean base. What's your base? Okay. So these are very defined. A has to be positive, not even 0. Okay. And A is not 1 again because remember 1 is just like worthless. 1 to any power is 1. We're not going to talk about 1 to any power. We're just going to talk about 2 and 3 and 4 and 1/2 and 1/6 and all those. Okay? All right. So if A has to be this domain of the, let's just try some out. Y equals log, let's just do log of x. Since we have a log key on our calculator, let's just check it out and see what happens. And then we'll talk about what base that is. So we're going to graph it. I'm going to clear what I got here. Go ahead. You've probably seen that log thing somewhere along the line here. It's right here. So you want to use trying to be very efficient here. All right, your log right here. Okay, so log, we won't worry about a base right now. There's an assumed base, but we'll talk about that later. Log base x, or log of x, is a graph. I have a really terrible window, so let me change it to what you probably have, which is your standard window. And yes, I have some grid, but that's what it looks like. Okay? Now, just to be clear, this does not stop here. What does it do? It hugs right here. Wow. And it does this. Okay? So that is a vertical asymptote. Okay? X equals 0. Okay? Notice what the domain would be. This is what we're after. What is the domain? Think about what x's I have put in to make this. Notice? What x's did I put in? Positive values again, right. So not counting 0, but anything beyond 0. Okay? Positive numbers again. Here's what we're going to talk about. This number sitting right here. Log base A of x equals y. X is called the argument. I didn't name it. Okay? And the argument must be positive. Okay? If you don't believe it, go back. Sorry, I didn't do that. Back to the log full screen, log of -4, and it'll give you an error, okay? In real mode, all calculations must result in a real number. So it does not compute because it just, and you'll see why here in a minute too, okay? So we'll be referring to that argument. That argument must be positive, okay? Does anybody have a question on this first page? We're just kind of getting used to the log, all right? Okay, so you're supposed to be noticing that the log is the exponent. Every time I turn the page, that's going to do that. These notes, a log is an exponent. So when I ask you what's a log, the answer is an exponent. Okay, yes, Alexa. All right, the log is an exponent. Okay. Now, what we want to do is we want to switch back and forth with exponential and logarithmic. Okay, y'all good? All right, so I put 3 in. This will stop eventually. Okay, I put the 3 in. Now, what we want to do is we want to say this is y equals log base 3 of x. 3 is the base of the exponential. That's why we call it a base of a log. It's the same base, okay? Now, what's the log equal to? Okay, so what's going to go here? Y, because y is the log. Y equals a log. So what else is left? Your x. Okay, so this right here and this right here are what we call equivalent statements. They are not inverses. They are exactly the same, except they're written differently. Okay? One's an exponential form, and the other is log form. Okay? And you need to be able to do that fairly quickly because that's going to help you the most. So the next page is all about that. Are y'all ready? All right, let's go. Okay, change each exponential to log. Change each log to an exponential. Okay? If you have to look at for the right now, that's fine. Okay, so log. Oops. What's my base? What's my base, Amanda? Of my exponent. Okay, so that's my base of my log. Remember, I'm just changing to in a different form. I don't want to change up things. Okay, my exponent is what? Melanie, what's my exponent up here? 8. So that goes there because my log is the exponent. The only thing left is right there. So that is the equivalent statement. 5 to the 8th is t. Log base 5 of t equals 8. The log is the exponent's 8. The base is 5. The other one just falls into place because there's only one other place to do it. Yes?
Is t like raised up or is it supposed to be?
No, t is straight up. This is like a subscript when you write it, like this is what it would look like. T would be right. Yes, good question though. Do you have one?
What is this?
Well, we're getting there, Rachel. Calm down. All right. X to the -2. Who thinks they got in log form after 2 examples? All right, Melanie. Log
X.
base x.
Base X.
Okay.
12.
Okay. Very good. Log base x of 12 equals -2. It's totally nonsense right now. I agree, Rachel. Totally nonsense. Because we're not doing anything with it. But you got to get used to the nonsense so you can do the real stuff. Okay. Now, E. Have we talked about E? Yeah, we talked about E when we're doing exponents. Okay. Yes, Alexa, go for it. Base E.
Base E. 10 equals 10.
Okay. So read it to me correctly.
Log base E.
Of 10.
Okay, log base E.
Nice. Okay. Now, little exception when using E as a base. We have a different L, and it's called a natural logarithm. So that's the N in natural L. That's assumed right here. These are the same. We don't usually write it like that, but you didn't know that when you did it with me. But E is a base, you use ln instead of log. Okay? That's your assumed base, and you usually won't even see that. Okay? If you look at your calculator, just so you know where that one is, probably never used that one before. Where is that calculator? ln is right below log. Okay? So here's your ln. Your base assumed is E. There's an assumed base here, but we haven't talked about that yet. We'll come back to that. Okay? All right, good job. Let's finish up here the logs to exponents. All right. You want to give it a shot? Go ahead, Lauren. Ready? Nice. Power log base 2, so that's the base of your exponent. Your log is your exponent, so there it is. The other place is 21. Good job. All right. The next one. Go ahead, Sarah. Very good. Log base Z, there's your base of your exponent. Log is your exponent. 6 is your exponent. 12. Good job. Okay. What about the last one? Leah? 2 is your base. Your log is your exponent. So what's your exponent? A. Okay. Okay. 2 to the A equals 10. Okay? So you'll be wanting to switch back and forth because we're more comfortable with this and we could solve this. But that would be tough to solve if it wasn't in this form. How would you solve that one for Z? How would you solve Z to the 6 equals 12? Take the 6 through it. Very good. Okay. All right. We got to remember the log is an exponent. Okay, so without a calculator, how do you find the log of base 3 of 81? It's got to be a number that you can relate to. Okay, that you can figure out without a calculator. All right, I'm going to let it equal x because that's what I'm looking for. Okay, now I'm going to put it in exponential form. Lydia, could you do that for me? Okay, now this is like what we did for homework, except simpler. What's x? Lydia? 4, yes. Because 3 times 3 times 3 times 3 is 81. That's 4 3s. Okay. So when you're solving a log, you want to switch it up to be an exponential form. All right, Lauren Chambers, can you switch this one up to exponential form? Well, you got 2 choices, 1/8 or x. All right, there you go. Equals 1/8. Okay. Now, again, this is like what you did for homework. You would probably leave the 2 to the x alone and write the 8 to be 2 to what power, Claire? -3. So x equals -3. Okay? So this equals -3. Okay? This equals 4. So there's a lot of logs that you can do, and you can change the base on the lot of logs, and you can do those without a calculator. Okay? Back in, like, when I was your age, we didn't have those fancy calculators. We were doing writing on rocks. I'm just kidding. They had us do a huge multiplication with logs, and I can show you that when we get into the logs. But there was more of a purpose to a log now than there is now. But there still is a purpose, but not as big as it used to be back in the day before we had the calculators. Okay, so let's talk about the domain and range again. We already said, oops, we didn't say that. But here, I guess we should say it. Log is the inverse of exponential function. Okay? Let's look at the graph here again. We have log of x. Okay, before we do this. Okay, I guess I'm going to have to reveal here what the assumed base is. Anybody have a guess what the assumed base is? What do you think it is, Rachel? No, not 1. Can't be 1. That base cannot be 1. It's not 0, can't be 0 either. It is 10. Remember our decimal system, even the DEC, what is that, prefix? That means 10, right? Decimal, decade, okay? So our decimal's in terms of 10, so that's the assumed base. Okay, so that's, when we graph that, that's what we graphed, okay? Let's switch it to the inverse. Let's do 10 to the y equals x. Okay, first of all, that's not my inverse, right? Those are equivalent. Now switch it to my inverse. 10 to the x equals y, okay? So the same, just to be clear, this is the inverse. All right, now put that in your calculator with the log x that you have. So 10 to the x power equals y. All right, here they go. There's that. Okay. So that's what they should look like. Your blue is 10 to the x. And this, remember, doesn't stop there. It goes like this. Okay? Probably a little bit. Okay? That's y equals log of x. And that's, okay? Now, do you all see that that's A inverse and inverse now? Split. That's what inverse does. It flips over that reflective y equals x line. Okay. So that's your visual proof, but, you know, there's kind of a proofy too. All right. So let's move this out here. Here. Okay. Now we're looking for domains. Okay, before we look at the logarithmic function, we already talked about the domain of the logarithmic function has to be, the argument has to be positive. So that's what this is. And if you look at, so bring this back here for a minute. Okay, the range of the exponent is also positive. And that's how inverses work, right? The domain of the one is the range of the other inverse. Okay, and the range of the logarithmic, okay, all we got is, we got all the numbers used up here. So that's why it's negative infinity to infinity. Okay, so let's find, oh wait, dude. All right, let's find some domains here. Now, what did we say we called this right here? Search for the name. Argument. The argument must be positive. So x minus 2 must be positive. What do you know about x? If x minus 2 is greater than 0, what do you know about x? It's greater than 2, so what's my domain? This is f. What's my domain in interval notation? Lindsay?
2 not including 12.
Nice. Okay, good job. So that's the domain. All right. So you're going to be doing some just basic inequalities. All right. This would also be the range of the inverse if we were going there. We're not going there right at the moment. Okay. All right. What about this? Log. The argument must be positive. So x plus 3 over x minus 1 must be positive. Okay, this has to be greater than 0. All right, that's how we figure out the domain. Okay, now, I don't know about you, but that makes me think of last chapter. How did we do a rational function inequality? Because that's what we're doing. That's not just part of this problem. Lydia?
The name is 1 not included to infinity.
So 1 to infinity?
Yeah, and is there a union before that? Of like,
I don't know, I asked you first. Okay, I asked the question, how did we do it? So let's not jump ahead, let's save this, maybe she's right, maybe she isn't, but how did we do a rational inequality? No.
So you only count the denominator because technically as long as it doesn't equal 0, it should be positive.
Okay, it's just, if you don't want the denominator to be 0,
No.
but you also want it to be positive. Remember, in rational, sometimes they look like this, sometimes they look like this, and then they got something like this, and something like this. I mean, they're all weird. What did we do? If we didn't graph them, what did we do? Say it again, Claire. Interval test. So let's do it. Interval test for rational functions, inequalities. Okay. Where am I going to split my interval? Certainly at 1, right? As Melanie mentioned that we can't have 1 being and -3 is the other one. Good job. Okay, Julia? Good work. Okay. Now we're going to interval test. I guess we could try out a -4, a 0, and a 2. All right. We're just looking for negative and positive. -4 plus 3 is going to be what? Negative or positive? Negative. And -4 minus 1 is another negative. So a negative over negative is a positive. Okay, 0. Is it negative or positive? Rachel?
negative.
Negative. Good job. And 2? Okay, now negative or positive?
I don't know.
Good job. Okay. So now, what's my domain? Where is my argument positive? Maybe.
Negative infinity to -3, not including union, not including 1, to infinity.
Very nice. Okay, so you have part of it. Okay? So, pretty detailed, building, but, it's part of, you're supposed to not remember now anything from here on out, ever. Especially when you get to calculus. Okay, any questions on those 2 problems, domain and log functions? You good? Okay.
This one,
Yes.
every time I try to write my one, it just like shuts down.
I don't know.
Could you come back for just a second? Thank you.
Yeah, you might want to go back to your smart if that's causing you issues. I could tell you to restart, but then that's a whole nother 5 minutes later, and then you're behind the 8 ball. But yeah, that would probably take care of the problem.
So why would you do the middle school?
Because it's negative, and we want it to be positive.
Oh, so it needs to be.
Just has to be there.
Yeah, because it's a log argument. Yes, so it needs to be positive. Yep. Okay. And we're off. Okay. Oh, you ready for a brain break?
Yeah.
All right, let's do it. Oh, where'd it go?
It's on the dark one.
No, it's not any good. Oh, it's this one.
Oh.
Come on, stand up. Okay, who's gonna just dance here? Here it is good? I'm gonna leave it good too. Bonnie, stand up. I can't do that in my leg. I'm really not. I'm concentrating. Oh, Kelsey, come on, where's your energy? I'm supposed to get it to you. Nice and slow.
We should go up and y'all.
Chicken dance of sorts.
What kids dance to this? Like, am I crazy?
Alright, I think we should be about that. Go let this next thing.
Watch it like an hour long.
Wasn't that good? Justin,
Always dance.
last year my juniors didn't want to dance. They were like,
I don't like
I guess juniors, they were all about it.
About it.
Okay. So we really already talked about this, so I'm just gonna, oh my gosh, we just skipped all that. All right.
I wish I could see us doing it though.
Well, they can see you do it, they just saw this. Okay. So we talked about this. Remember, we have this, and we have this. Okay? So let's just move on. Let's look at the properties of logarithmic. I'm going to circle the ones that would be helpful to just know. Okay? The domain is a set of positive real numbers. Definitely you need to know that. Okay? The range is a set of all real numbers. Okay? And remember, when we're looking at the graph, this is your logarithmic one. This is the one we're referring to right now. All the y's, remember these are your y's, they're all going to get covered. That's why the domain is the real numbers. Okay? Let's see. X-intercept is 1. Okay? Remember on your, this, we had 0, 1. Well, now we have 1, 0. Imagine that. We had to flip them around because it was the inverse, right? Okay? So again, it's common sense if you understand the concept. No y-intercept because we're not going to cross over. All right? This is the log one. All right? The y-axis is a vertical asymptote. That would be helpful to know that that's just going to hug that and not stop like it looks like your calculator stops it. It does not. So keep that in mind. Okay? It's decreasing. The f contains those 3 points. Again, if you're confused, you plug in 1, 0, a, and 1 over a. You'll figure it out. Smooth and continuous with no gaps or corners. Okay. All right. And that would probably be helpful to remember that. We are not going to do that, but a lot of it is common sense. Okay, so let's look. Oh, that's where my brain break is supposed to be, but anyway. Okay, let's look at the natural logarithm again. The natural logarithm is what we'll use in calculus, okay? Because it's just bigger than the regular logs. There's a lot of reasons, most of which, you know, if I told you, you were going, okay, I don't know what that means, so I won't bother. But it is way more important. Okay, the base of a logarithmic function is number e. That's the natural logarithm, ln, log natural. Okay, this function occurs frequently in applications, so it's been given a special symbol. But here's the thing, you will not see the e unless you put it in there. You will not see it. So if you're going to switch back and forth to exponential, you need to put it in there. Okay? So these are inverse functions, because this went to x equals e to the y. Remember, that's the same. Sometimes if you start with the exponent, or don't start with the exponent, and you start with the other side, it's confusing. And then when we switch that around, that's what we do. Okay? So those are inverses. All right, we're trying to get to some meat here for you, Rachel. Okay, find the domain of f of x equals 3 ln x minus 1. Okay, domain is what we can put for x. X is in a parentheses. We would call that the argument of log. Okay, so what does the argument have to be? Positive. X minus 1 is greater than 0. X is greater than 1 or 1 to infinity. It's your domain. Okay. All right, so graph. Okay. Now, let's think about a transformation. Okay. Let's think about y equals, this is y equals log base. Oops, that's ln, sorry. ln of x, right here. E, if you want to put it in there, go for it. Okay? That's the basic. Okay? Now, what happens in this case, our vertical asymptote is y equals 0, x equals 0, sorry. Okay, it does that. This affects it. We know it's going to be 3 times as big. So this, if it was just this, let me do this. If it was just this, we would make this times 3, we'd make this times 3, and it'd be like this. Okay. All right, what is that x minus 1 going to do? It's going to move it to the right because it's inside, right? So we're going to take this, good job, Claire, and move it to the right 1. So here we go, right 1, there it is. That is y equals ln of x minus 1, okay? So we probably should have moved it first and then multiplied by 3. So this now gets, that's 0. 0 times 3 is still 0, right? Okay, so finally I'm going to get to this. 0, that I did that wrong. Okay, and then this is 3 times as big. This is 3 times as big. Oh gosh, well, okay. So it's going to go like that. Okay, so once we go through all of that, of course, you can see now I moved it over. Where's the vertical asymptote now? X equals 1, that's correct. Oops, vertical asymptote. Okay. And it would have been maybe, okay, so let me graph here. All right, so we did our ln in black, ln of x, okay. We did green with just x minus 1, so we go down to the green, ln of x minus 1. And we did blue, put them all together. Okay, 3 ln, oh shoot, did I do that? 3 ln, thank you for telling me that, x minus 1. Okay, so there they all are. That's the one we really want, the blue one. You can see a lot better there than I did. And you can see it's, you know, it comes down like it's supposed to. For some reason, the graphics on this calculator just make it stop there. I don't know why. Okay? So the blue one is the one. What's the range? All real numbers. Good job. Okay? We're not going to go crazy with the transformations because we'll do mostly matching, and you'll do that right, left, up, down, and big, stretching and all that. But we're not going to go crazy for the stretch because it just gets so tedious and you're a little bit off. And anyway, okay? Are we good? Alrighty then. Okay. Same function. We're going to do the inverse. Okay. You think you all can find the inverse? Go for it. Go for it. Do you have a question?
No.
Ranges negative infinity to infinity, vertical x equals 1. Okay. Looking for an inverse? Negative infinity to infinity. All right. Now, who's changing to exponential notation or form? It's a good plan, but the 3 is going to be in your way, so get rid of that 3 first. Because how do you get rid of something that's multiplied? Got it. So that's how we get rid of it. Now change it to exponential form. What does exponential form look like? And then switch it out. And then we just assumed base out and in. All right. Lindsay, you got an exponential form yet? Okay.
Actually, yeah, I do. I don't know if it's right.
Okay.
Okay, I had ln times
That still sounds like a long form.
E.
Okay.
E times E like exponentially raised to the y over 3.
Okay. There's
Or else
E.
the wrong one.
Okay. E to the y over 3 equals.
X minus 4.
Nice. Okay. Now you switch out your x and y's and you're almost done. Okay, this is still this, which is still this, which is still this from the beginning. We haven't changed anything yet, we just changed form. Okay, so what does the inverse look like? Aaliyah. Okay, you're almost there. Y equals. Nice. There's your inverse. Okay? So if you're going to switch to that exponential form, you got to have ln x equals y. You don't want anything over here. That's going to mess you up. Okay? All right. Now, I would expect you to graph that one without a calculator. So let's graph it. We're all ready to go here. Graph. Let's see. This is an exponential. So wait, before you graph it, anybody graph it yet?
Yeah.
Oh, okay. Who's yeah? Who graphed it? Okay, don't tell us. You're too quick. E to something plus 1. What should that look like? Of sorts. What does E to the something look like? Think left. Think down. So this is E2 at x power, right? We'll just say it's x-ish. Okay? And then that 1 goes up like this. Okay. Are we right, Claire?
Oh, yeah.
E to the x over 3. It changes the exponent, rise a little bit, but it's going to be up there 2 because it raised it 1. So you have the right idea, Melanie. Don't beat yourself up over that. Okay? So there's your, okay. Function, what's my domain of that function? Alexa? All real numbers, nice. Okay. And my range is what? Elena?
1, 2.
Nice. Okay. Now, we didn't graph the inverse. We could, did we? Oh, yeah, we did. Is it 2? Yeah. Usually it's 0.
Oh,
We erased it. Remember that it doesn't go below the 1 this time. So your y asymptote is y equals 1. Your horizontal asymptote. Okay. Nice job, Elena. Okay. We had it graphed over here. There was the blue one. Okay. What was the domain over here? We never did that, but check out the range is the same as this domain. Okay. And the domain should be the same as the range of this guy, right? Is it? If you look at the blue function, is it? We start with 1 and go over, yes, we did. Okay? Now we know that in our head, but don't forget about that little detail because it'll help you find other things. Domain is a lot easier to find than range. Yes, ma'am. Correct, but doesn't it go? Oh, that's true. Below the 1. I'm glad you like to question me, Connie. I really am. But I gleefully laugh inside when you're wrong. Yes, Rachel? Well, the horizontal asymptote is the same value as the vertical asymptote, remember? Because they switched. So again, that makes sense. So sometimes if you can't figure out, oh, what's that? You know, then you can go with the one that you know better, like you've known him for 2 days, the e to a power as opposed to the logarithm that you're just meeting. So anyway, sometimes it helps to have a few ways to come from. Okay, anything else on this page? Are we ready to move? All right. Why that button is not working for me. Okay, common logarithm. All right. I've already exposed this. Did I not? Yes. The common logarithm, if you see that log button on your calculator and there's no log, there's no base, it's not. Nothing is 10, and we talked about why, because our decimal system. Okay. So, again, just to reiterate, if the base of the log function is not indicated, it is assumed to be 10. Okay? You want to put that in there just for, like, because what you're doing with it. Okay? All right. Let's use some logs. This is our purpose, Rachel. And she was worried. And I get it, and I appreciate that. You're like, are you serious? This is just nonsense. Okay, this is the purpose of a purpose. And this is probably the purpose that we're going to do with today. Okay. So what we want to do is solve this equation. Now, in what way does this look like the last, or does this not look like our last lesson? How does it not look like it? What could we do with the exponents last time?
There's a coefficient.
Okay, well, I can take care of that problem. Okay, so that was a good, I just divided by 2. Okay, now I don't have a coefficient, but it still looks different in what way? It's equal to something. Didn't we have equal to something?
Yeah, but it was.
We had like 2 to the 3rd equals 3x equals 8. And then from there, you went 2 to the 3x equals 2 to the whatever power, and then we dropped the power and we solved. Okay. So, what?
We can't make that
Well, yeah, we can.
without
A log, that's right. So we want to get it to both e to some power, okay? Now, I'm going to tell you why it works, but then I'm really going to tell you how to do it, okay? And I know that's pretty much why you're after. Okay, so I want 3 here. I'm going to erase this. I want 3 to be a power of e, okay? So can I call this y? I don't want to call x because I already got an x in the problem. That would be confusing. Okay, change this to logarithm thing. Yeah, but pretty much doesn't count in algebra. Only counts if you were grabbing ish. Yeah. Did you hear what she said? Isn't e pretty much 3? It is, but it's not 3. You want the exact answer, and it's not going to be 3. Okay? For the most part. All right, so somebody switch this up to a logarithm problem for me. 3 equals e to the y. What is the ln? Go ahead, Amanda.
Y equals log b 3. Find log base e of 3.
Equals y. Okay? All right. Very good.
Wait, did you say you could just write on?
Yes, that's the same thing. Okay? Now, let's take out your calculators. Go back to your common, just your home screen, and find the ln of 3. It's so dirty. Okay. All right, now, remember they've rounded it. It's stored in there, but let's take e to the power and then put that answer in there. Do you know how to do that? Second answer. Don't type it in because you're typing in the part that you can see. That's not the stored part. So second answer, press it, and what the heck? What happened? E to the power of the answer. And we're back to 3. Okay? What the heck did I just do? Okay? We said this 3 was e to the ln 3, correct? I'm going to show you how to do it better than I just did, okay? Because we don't have to do all that. But that's now 3x equals what? Woo! You all didn't tell me I was running out of time here. All right, let me get you. Can I just put it on LMS or do you go ahead? Yeah. Okay. Just look at that.
I got 3.0.
Yes. But did you put it back in or did you get the answer?
I put it back in.
Okay, that's the short answer. That's not the answer. That's
the second.
That's weird, yeah. Okay, but yes, that's the same idea. Okay. So let me give you some problems that you're ready to do. I figured we'd run out of time. You shouldn't have done that. Okay, on chicken dance.
No, it's worth it. You're so recording.
Oh gosh.